Hey guys, welcome back to this 100-day challenge for DevOps and Cloud. And today is day 11. Today we are going to talk about 11 different tools related to container orchestration. And also we will try to understand quickly how these tools are different and where it can be suitable for us so we can take the better decision for our organization while choosing the correct container orchestration tool. It can be your Kubernetes, it can be your OpenShift, it can be Nomad, it can be Ransom. So let's see which tool is suitable for us and what tools we want to use it. So let's start without wasting time. So guys, let's understand these tools one by one. So first tool we are having Kubernetes. As you know, it's a open source and it helps to manage many containers in a smart way. So that's why it's a useful for managing containerized application at larger scale. So if we define Kubernetes, it's an open source container orchestration platform that automates containers deployment, scaling, and management. So the unique feature of this Kubernetes is it's like the captain of a ship, making sure that all the containers work together smoothly. It's a super popular nowadays, and can run on different cloud services as well, and it's the most adopted container orchestration platform in the market. Let's talk about next tool, that is Docker Swarm tool. It's a open source and it's ideal for small to medium sized Docker deployments. So it makes handling a small group of containers very easy. You can understand it's like a friendly group leader, which is great for a small container gathering. So Docker Swarm is a native Docker clustering and orchestration solution that provide simple container management. Now let's talk about the tools from the list. So that is Apache Mesos, that also an open source and it's a distributed system kernel that abstract computer resources, making it suitable for building distributed systems. So it's well suited for large scale resource efficient systems. So it helps actually in big systems to share their resources in better way. So it's mainly useful for better resource utilization, and it's like a super resource manager which makes sure that computers share their power wisely, and it can even work with different application together. So it's one of the best tool we are having along with Kubernetes. Now let's talk about the next tool, that is Amazon EKS, that is Elastic Kubernetes Service from Amazon. And it's a managed service. What is the difference between managed service and open source? Like open source is available for all and you can utilize the same code, modify it, and you can use it according to yourself. When we are talking about the managed services, it's a responsibility of cloud service provider to manage all the infrastructure related to these services, and you just need to use that service and pay for the utilization you are doing. So it's a makes running containers on Amazon's cloud. So it's a perfect for deploying Kubernetes workload on AWS. So EKS is a managed Kubernetes service which provides by AWS, which I already mentioned, and it's simplifying Kubernetes deployment on the AWS platform. Next service we are having Google GKE, that is Google Kubernetes Engine. It actually helps to run containers smoothly on Google Cloud. It's a again a managed service. So whatever cloud is providing, they are providing managed services. So infrastructure they are taking care. You just need to use that services for your Kubernetes workload. So GKE is a managed Kubernetes service by Google Cloud, which offers Kubernetes deployment and integration with Google services. So it's excellent for Kubernetes user on Google Cloud. Similarly, if we talk about the Azure Kubernetes service is known as AKS. It's also a managed service, and it's a managed Kubernetes service on Azure cloud, which streamline Kubernetes management on Azure cloud platform. So the purpose of this service is to make running containers easy on Microsoft cloud. So it's like a wizard for your containers on Azure, simplifying their management and scaling. So it's great for Kubernetes deployment in the Azure ecosystem. As you know, if you are running Microsoft services in your organization, that it's a really a easy way to run Kubernetes deployment on Azure cloud for you because of smooth integration.
Now let's talk about next tool, that is OpenShift.
available like open source and commercial. So it's a Kubernetes based container platform which is provided by Red Hat, and it offers additional features and tools for containerized application deployment and development. So it's normally suitable for organizations with Red Hat technology or seeking an enterprise grade solution. So if you are looking for Red Hat technology related Kubernetes system, then OpenShift is a great choice for you. And the unique feature of this is it helps create and manage containers with extra features, and it's like a Swiss Army knife for containers, which offers lots of tools for developers, especially in larger organizations. Now let's talk about next tool, that is Nomad. Nomad is a open source tool, and it schedules and manages different types of tasks. So Nomad is a open source workload orchestrator by HashiCorp. So we are having Terraform from HashiCorp, right? Similarly, we are having Nomad as a Kubernetes, or we can say container orchestration tool from HashiCorp that schedules containers, virtual machines, and applications. So it's like a flexible task planner which handles not only containers but also your virtual machines and applications. So if you are have mixed kind of environment like virtual machines, applications or container, then Nomad can be a very useful tool for you and for your environment with diverse workload to orchestrate. Now let's talk about next tool, that is tool number 9, that is Rancher. It's available as a open source and commercial like OpenShift, and it's provide an easy way to manage Kubernetes and Docker all together. So Rancher is a open source container management platform with a user friendly interface for Kubernetes and Docker management, and it's good for organizations looking for simplified Kubernetes and Docker management. If you want to manage both the things like Kubernetes and Docker, then Rancher is great choice for you. Now let's talk about next tool, that is Container D. So Container D is a industry standard container runtime. It's not a complete container orchestration platform, but it's an foundational component in container orchestration platform. So it's available open source, and fits as a container runtime in container orchestration solutions. So it's like a silent worker, we can say, behind the scenes, making sure containers run smoothly without lots of extra features. And also it take care of basics of containers which are running on our platform. Now let's talk about next tool, that is Portainer. That is the last tool from the list, and it's offer a simple and friendly interface for Docker. It's available as a open source and commercial. It's available for free as well. So Portainer is a user-friendly container management platform that simplified Docker container management with a graphical user interface. So it's available as a GUI. So if you are not comfortable with the command line interface, then you can use this tool and you can run your containers as well and manage efficiently. It's ideal for organizations and users who is looking for an easy to use Docker management tools. So the thing is, we have seen 11 different tools, but these tools has its own special features and uses. So on the basis of these uses, you can define your use case. So understand first your environment, which tool is suitable for you. Accordingly, you can use that tool. It's not like if you want to manage everything and you just going with the Kubernetes. If you are as we already seen that for that one we have a tool called Nomad, which can do everything, like it can manage your containers, manage your virtual machine, manage your application. So each tool has their own unique feature, right? Just go through them, explore more so for better understanding, and also mention in the comment section which tools I need to cover in detail. Normally we are going to cover Kubernetes definitely, but if you want other tool, just let me know in the comment section. Now it's time for you to support me. Just like this video, share with your friends, subscribe this channel for more learning content. See you tomorrow with new concept related to container orchestration. Hey guys, welcome you all in day 12 of our 100-day challenge, and today we are going to start a very important concept in DevOps, that is Kubernetes. It's a best and popular container orchestration platform. So we have already talked about containerization, and container orchestrations platform. So Kubernetes is one of the best platform we can say and most popular, which is used in many organizations. So as a DevOps engineer, it's better you learn this tool very soon. So in general, if we talk about Kubernetes is a tool which is a open source and it's a container orchestration tool that automates the deployment, that means your provisioning of your applications inside the containers, and scaling and management of containerized applications. So what exactly the Kubernetes is, this is the general definition you will get everywhere, but in simple term you just understand this thing. Kubernetes is an open source orchestration tool which is developed by Google for managing the microservices and containerized application. So this is how we can define simply. Let's define it again. Kubernetes is an open source container orchestration tool which is helpful to manage microservices and containerized application, and it is developed by Google. So Kubernetes actually provides highly resilient infrastructure with zero downtime deployment capability. That's why many organizations are using it. If we talk about the features, it has many unique features that help you to run your business 24 by 7. That's why many big companies are using Kubernetes. So Kubernetes has the features like automatic rollback, scaling, and self-healing of the container. That means which consists of a auto placement, auto restart, auto replication, and scaling of containers on the basis of CPU usage or the memory usage. Based on your utilization, it can place on the required node. So these are the unique features that makes it more popular. Now the next question is, it is developed by Google. Still it is belongs to Google? No, because they open source this tool in 2014. So now it's not belongs to Google, it's a open source now. Now the next thing is what actually orchestration does. So the thing is, it do efficient resource allocation, load balancing, self-healing. These are the few features that orchestration do. But in actual, if we talk about, it can configure and schedule your containers. It can provision and deploy your containers. It can provide high availability of your containers. It configure of the application that run in a container. It can also load balance, traffic routing, and service discovery of the containers. So there are many things. Even it can help you to health monitoring of the containers, securing the interaction between the container. So we will go through these one in our upcoming session. But for the timing, whatever you can think about that can help you to run your business 24 by 7. Most of the things provided by this orchestration, and Kubernetes is providing these all features. Now the time to talk about some famous container orchestration. So if you will go to Google and search container orchestration tools, so you will see the list what we discussed yesterday in our session, like Docker, Kubernetes, Apache Mesos, OpenShift, Rancher, Microsoft Azure. So these are the famous container orchestration tool, and these provide the features what we already discussed. Now it's time to understand about the Kubernetes architecture. So let's go to the Kubernetes architecture. Although we will go in much detail tomorrow, but for the timing, we are just covering what we need to learn out of them. So there are many way to define your Kubernetes architecture. It's all depend on your requirement, because you can have your single node, you can have multiple node, you can have your in cluster Kubernetes cluster in your physical host, on your virtual machines, on the cloud. It's all depend, or even you can have the mix of that one. So as per your requirement, we can define our Kubernetes architecture. So let's check one of the image which is mentioned here. If you see, there are two things here: worker node and master node. Here we are having two worker node, here we are having one master node. So the thing is, this master node, whenever we need to communicate anything, we need to work on this master node, and this master node will interact with kubelet, which is having on this worker node, and whatever workload will run, your container will run here. But directly, you cannot see these containers, because in the Kubernetes system, pod is the smallest unit that you can deploy. What does that mean? Whenever you need to run any container, you need to execute the pod. Once the pod is created, your container will run inside the pod, and it will all will be managed through these pods only. Means all the containers, your application will be managed through these pods, and this Kubernetes infrastructure will deploy these pods. And how this pod will look like, how you need to define it, that we will also look. And whatever components you are seeing here, like API server, controller, scheduler, and key value store, that is our etcd or etcd, whatever you name it. So the thing is, these are the four main component of your master node. Here you can see kubelet, container runtime, and network proxy. These are the main component of your worker node. And whatever component you are seeing on your master node, so again a container itself inside the master node. So how it will be? It will not be a different type of component. It's a container inside your master node. And how you can access this API server? It can be accessible either through the CLI, that is kube control, kubectl, that we will look, from where you need to run the command, and that kube control will connect this API, interact with this one, and then it will give the command to these internal components. But if you want to directly connect with these components, you can do it. You can directly connect with the API server, then communication will establish accordingly. They will care the role for what it is assigned. So when we are talking about the API server, here it's the primary management component of your Kubernetes, and it's responsible for orchestrating all the operations, whatever we are talking about, scaling, updates, and on. Or in the sense, we can say it is the act as a gateway to your cluster. If we talk about the scheduler is actually identify the right node to place your container based on the resource limitation. If we talk about the etcd, this is a critical part of Kubernetes because it's a etcd database that stores the state of your cluster, including nodes and the workload information in a key value format. How it will look like? Let's have a look on one of the definition. So now we come to the Kubernetes side, where we try to understand how the pods will be defined, how our container will be defined. This is just a review session about the Kubernetes. And also, while going through the exams, you will have access to this platform as well. That means you will be able to access this Kubernetes.io website from in your exam as well. So it's kind of open exam, but you need to perform some tasks for your certification exam. But you will have direct access to this one. So you can directly copy from here the files, and then you can modify according to your activity which is assigned in the exam. So let's understand what is pod. So if you see, a pod is a group of one or more containers. That means the pod will run one or more containers. So how we can define? It's a sample file of a pod. Here we are defining pod. Here if you see kind is pod. That means this file is for the pod definition. Here the name of the pod you can see here. Inside this one you can see the specification where we are defining containers information. What is the information we are defining? It's a name of the container, and then image of the container, what it will use and what will be code for this one. And whenever we need to create the pod out of this sample file, we need to run this kube control apply command, and we need to give the path of this file. This is the simple way to create your pod. Actually, there is two way to create your containers or pod. Either you can use YAML file or you can use the command line interface. So we are having both the way. This is the best way to define it because here you can see the definition what you are assigning, or you can use the commands as well. So what are the commands we are having? If you see this one, command line tool, here you can see all the commands. Okay, so it's kind of a kubectl cheat sheet. And the commands which is mentioned here, it is already given that it's for Kubernetes version 1.28. To check the version, you can use this command. Next thing, most of the time what will happen in the exam, you will directly search for the pods and all, okay, that you need to define in your exam or perform activity. But most of the things you will get it here. For example, you want to fetch the resources, right? You can directly go here and check the commands for fetching. If you want to upload the resources, you can go directly here. And now come back to this point. Okay. Mm. Okay. After pod, what you want actually? You want to scale it, right? For that one, we have a term called replica set. And in the replica set file, we have the term called replica that will define that how many pods you want to run for your environment. So this file can help you if you want to run a pod with three replicas of that one, that you can do. Even you can use some command through which you can increase or decrease of the count of your pods. Now let's see where you need to do to get these all things. So the website is kubernetes.io, where you will get everything, whatever you need it. You can see here the documentation are available, blogs are available, training is available, case study also available. That will be helpful because being a single person, you can't go through each and everything. Whatever you need it, you just need to come to this website and then you can get it. Whenever you need anything, you can just search here. Accordingly, you will get it, and all the documents, concept, labs, everything related to that term, you can get it here itself. You can search it, you can access it, just to get familiar with this platform, because it is very useful while you are going through the exam or you want to learn Kubernetes thoroughly. So guys, that's it in this video. I hope you find this video helpful. Join me tomorrow when we will deep dive. Hey guys, welcome back to our 100-day challenge for DevOps and Cloud. And today we are going to talk about Kubernetes concept and its architecture on day 13. So welcome again. And as you know that Kubernetes is an essential component of modern DevOps and cloud-based application management. That's why we are covering this in too much details. We will explore the key concepts here, advanced features, and various Kubernetes architectures. Now let's talk about what you are going to learn from today's session. So first we will understand the Kubernetes fundamentals that will help you to acquire a solid understanding of the fundamental concept of Kubernetes, which includes pods, services, replication controller, deployment, container runtime, and help you to work with containerized applications effectively. Next, we will explore advanced Kubernetes features such as stateful sets, daemon sets, and config maps that will help you to gain the knowledge needed to address complex deployment scenarios and applications requirements. Next, we will talk about the Kubernetes architecture. So here you will be able to explain the core components and architecture of Kubernetes, either it is single host or multi-host or in the cloud. So you will be able to explain each and everything about the Kubernetes architecture. So you will understand the role of control planes and worker nodes in Kubernetes. Next, we will compare these environment like on-prem and cloud deployment. What are the key features? And we are having different kinds of environment available and how we can use them as per our requirement. Next thing, we need to understand the importance of Kubernetes in DevOps. So here you know that how Kubernetes serves as a crucial tool in DevOps practices that we will see, and then you will be able to recognize how Kubernetes automation, scalability, and reliability contribute to efficient application deployment and management in DevOps workflows. Next, it will help you to prepare for further learning. Like if you, by the end of this session, you will be equipped with the fundamental knowledge which is needed to explore Kubernetes in more depth. So what will help you? So it will help you whether you are looking for a career advancement or the certification, or you are looking for advanced coursework in DevOps and cloud computing. It will help you and aware you for the next steps in your learning journey. So without wasting time, let's get started. Now let's talk about something related to Kubernetes basics. So what exactly it is? It is an open source container orchestration platform for automating deployment, scaling, and management of containerized application, or we can say it will help us to orchestrate microservices and containerized application. So this is the definition, you can use it. Next thing, why we need Kubernetes, right? So actually Kubernetes provide a number of rich features. That's why we are using these features are like automation, scalability, and high availability. When we are talking about automation, like it automates many of the tasks which involved in managing containerized application like deployment, scaling, or load balancing. If we talk about the scalability, Kubernetes can scale your application up or down automatically based on your application demand or requirement. This can help you to improve the performance and availability of your application. Also, Kubernetes ensure that your application are highly available, even if some of the nodes in your cluster is even your application will up and running all the time. That's why we need this Kubernetes very much in our modern environment. Next, we are having the benefits of using Kubernetes. So Kubernetes provide increased agility and innovation. It reduce the cost and also It improved application reliability and security. So that's why we are using Kubernetes because of its benefits. Now let's talk about the Kubernetes basics concepts. So first concept we are having pod. So what exactly the pod is? Pod is a basic unit of computing that Kubernetes manages, and a pod is a group of one or more containers which share the same storage and networking. So it's like in your pod, it can be one container or it can be a group of containers within a single pod. And it's a basic unit in Kubernetes that you create or destroy. Next concept we are having nodes. Nodes are like your virtual machine or physical box where these pods will be created and run. Okay, and inside that pod you will have containers, and in these containers application will run. Next concept we are having services. What exactly the service? It's an abstraction that defines a logical set of pods and a policy that will help this application to access. So services provide a way to expose your application to the outside world. If you want to use this application over the internet, then you need to expose it on some port. That's why this service come into picture when you are going to expose your ports to the outside world. Next concept we are having deployment. So deployment is a declarative object that describes the desired state of your pods, and Kubernetes will create or update the pods as needed to match the desired state with the help of this deployment. Next concept we are having replica sets. What is replica sets? Replica set actually ensures that a specified number of pods that you define are running at all the time. If a pod gets fails, the replica set will create a new pod to replace the terminated one. So it will make sure that whatever number you define, it will be created to the desired state. Next concept we are having container runtime. What exactly it is? It will create containers and manage the containers within the node, we can say. And this is like a example of Docker or containerd, whatever container runtime your Kubernetes uses. So these are the basic concept related to Kubernetes. So now it's time to talk about Kubernetes architecture. So before deep diving into that, first let's understand the component of Kubernetes architecture. Okay. So first component we are having control plane. As the name saying control, that means it controls everything within the Kubernetes. Normally there are two names. Either we can tell master or we can say control plane. So in this one we are having four basic component we can say, and but we are also we can have some advanced component or we can say the complex component of this node. So basic components are API server. Next we are having etcd. Next we are having scheduler, and then we are having controller manager. Okay. So these are the four basic components we are having within the Kubernetes, which do all the work managing everything related to the pods, containers, and take care of scheduling, take care of other controllers as well. Even when we talk about the API server, it's a main entry point for interacting with Kubernetes. If we talk about controller manager, that manages other controllers. If we talk about scheduler, which manages the scheduling of pods on which node it will go. If we talk about etcd, it's it's only communicate with API server and holds key value pair is in its database. Okay, so these are the core components of control plane. If we talk about the worker nodes, so worker nodes are the machines on that our pods are running. So worker node communicates with the control plane to receive instruction and report on their status. So whatever pods will run, it will run inside this worker nodes. So worker node also have some key components like it is having kubelet, proxy, and also it is having container runtime. These are the key component. Then the containers come into picture, which will run inside this one and the pod, which we already talked about. Next part is very important related to Kubernetes architecture. That's how these communication will be established between the control plane and worker node. So for communication between control plane and worker node with each other, we are using some API. So one is Kubernetes API, which is the main API, which is used to interact within the Kubernetes. Next, is kubelet. You see here, this is the component which is stored on or run on worker node, but it is responsible for managing the pods on. So if you see kubelet is an agent that runs on each worker node and is responsible for managing the pods on that particular node, and it also interact with this API server. So these are the core components. Now let's talk about Kubernetes architecture, how we can define it. So here we are going to talk about some high level Kubernetes architecture. Let's define it, how we can draw it. So here we are having master node. On this master node, we are having API server. And here we are having control manager, CM. Here we are defining scheduler. Okay. And we are having etcd database here. And you know, this etcd database is only communicate with this API server, not other component of this Kubernetes infrastructure. So this is how we define our master node. Now let's talk about the worker node, how it will look like. So it can have one or multiple. Let's talk about only one worker node at this point of time. Otherwise, you can draw other also. So the main component we are having kubelet, kube proxy. Then we are having container runtime. Let's example of Docker here. We are taking Docker, and inside this host we are having pods. Okay, and then within this pod we are running some containers. This is how we draw our Kubernetes architecture. Now, as an end user, here we are talking about the end user. Okay, when it need to communicate with Kubernetes, it needs some tool. The tool is kubectl or kubectl that we talked in our previous session. So what will happen? It will communicate this API server, and based on the command, it will function accordingly. So how the communication will take place? This kubelet is also communicate with this API server here. This control manager will communicate here. Scheduler will also connect here. And how the connectivity will be inside this worker node. This kubelet can communicate directly to the containers, or it can communicate to these pods as well. And we are having kube proxy, which will communicate with this kubelet, and also it will communicate with these pods. So what exactly this kube proxy do? Now let's understand the each component, what exactly it do. First, let's talk about the API server. So in short, API server commits all. So API server is the only component from the work. So what exactly the API server? So in here you can see API server is the only component from the master node which communicate with kube control and kubelet into the worker node. Now let's talk about one by one. First, let's understand the API server. If you see here, API server is only component from the master node which connects with the kubelet from the worker node. If we talk about controller manager actually manage other controllers, like we are having different controllers, the application namespaces and node controllers, etc. So it manages that thing, and it's also communicate with API server. Next, we are having scheduler. Scheduler, what exactly it do? It identify the right node to place a container based on resource limitation. So it will always look that which is the suitable node for any container. Based on this, it will place the container on that particular node. Next, we are having this etcd. So it's a critical part of Kubernetes, and it's a database that stores state of the cluster nodes and also workload information in a key value pair. When we are talking about key value pair, what exactly it is? Like if you we have seen some files, right, where we define like kind is a pod. So here key and its value. So similarly, if we need to define name of the container, we will define like this way. So it is the key value here, which is stored in this one, and also it also store the state of the cluster nodes. Okay. Next, we are having kube proxy here, right? That we did not talk yet. So kube proxy actually runs on each worker node to deal with the individual host subnetting, and it also exposes services to the internet. Pod you already know, it is the basic unit. Containers where your application runs. Docker is a container runtime which create these containers within the pod. And here we are having queue control or kubectl. It's a command line tool which help us to interact with Kubernetes. So these are the key components and the architecture of Kubernetes that we have to understand, and it's a high level architecture diagram of any Kubernetes cluster. Here you are having this CF. If we go in a cloud, we are having cloud control manager here. Now it's time to talk about some advanced concepts. So the first concept we are having is stateful set. So what exactly it is? It is used for stateful applications like where we need to keep our session active for the next phase. So it provide stable network identity and storage for that one. So this is very useful for stateful application. Next tool we are having daemon sets. So daemon sets, what exactly it do? It ensures that a particular node runs on all the nodes in the cluster, which is often used for cluster-wide tasks like logging or monitoring. So it ensures that particular nodes run on each node. Next, we are having config maps. So config maps actually separate configuration data from application code, which enhance maintainability and flexibility. So these are the key concept, or we can say advanced concept of Kubernetes. So these are the advanced concept of Kubernetes. Now it's time to compare Kubernetes environment in different scenario. Like we have taken three scenarios here. So first scenario we are having Kubernetes infrastructure is configured in a single host. It can be your virtual machine. It can be your physical host. Okay. Next environment is multi-host on-prem Kubernetes infrastructure where you are having multiple nodes like master and worker node, but these all infrastructure is configured in your organization itself. Next to environment is multi-host cloud Kubernetes environment, where these multi-host Kubernetes environment is configured on any one of the cloud platform. So first we are talking about the deployment environment. As I mentioned, here we will have single machine. Here we will have on-prem data center. These machines are hosted there. And in the last one, we are having this configuration on cloud infrastructure. If we talk about the scalability part, so as we are having only single host, so we are having some resource limitation here. So here we are having very limited scalability option. Here, if we talk about we are having multiple hosts, it's scalable, but when we are talking about cloud, it's a highly scalable because we are having the option to pay as you go. So you can configure as much as machine you want. Next is on control plane. That is our master node. If we are having only single node, that means we are having only one node where we need to install all the components. So we are not having option to distribute those components against other nodes, right? But in the second option, we are having that distributed control plane option where we can distribute our component to different nodes. If we talk about the multi-host cloud Kubernetes environment, here we can use managed control plane, which is provided by different cloud provider. We are having from Google, we are having GKE, that is Google Kubernetes Engine. If we talk about Amazon or AWS, there we are having EKS. If we talk about Microsoft Azure, here also we are having Azure Kubernetes Service. So these are the managed control plane. So you just need to focus on your workloads, not on the management control, means control plane or master node. Next, about the resource management, as we are having first scenario, only the limited control here because of less nodes. Here we can enhance more control because we are having multiple hosts here. In the last, in the cloud, control is done by cloud providers. You just need to focus on what type of container you want to run or application you want to run. You need to focus on your workload only. If we talk about the networking configuration in single host, it's a very simple. If it is multi-host, here you need to provide custom network configuration. It is a bit complex, but not too much. If we talk about the cloud one, here cloud provider do all the networking part. Next is hardware requirement for the single host Kubernetes environment. Very minimal hardware we need is the configuration part. But in the multi-host, we can custom that hardware setup based on our application workload. In the cloud infrastructure, yes, hardware requirement is fulfilled by the cloud provider, so we no need to worry about much here. Next is maintenance complexity. In a single host, it's always easier to manage Kubernetes infrastructure, but in multi-host it requires more management, and in the cloud one, provider manage everything related to the controller. We just need to focus on workload as I mentioned. Next is cost part. In a single host, always lower cost. If we have multiple hosts, it's a potential bit higher, but in the cloud it's based on your utilization, so here always you will have the variable cost. If we talk about the high availability in a single host, always there are a limited availability, because if that host goes down, then you don't have any other option to run your workloads. If we talk about multi-host, we are having enhanced clustering. Here we are having more availability than the single host, but still it's a lesser than the cloud one, because cloud provide built-in high availability, and their resources up and running 24 by 7 as they commit as per our SLA. If we talk about the use cases where we can use these infrastructure, if we talk about a single host, it's always good for development and testing purpose, not recommended anyhow for the production one. If we talk about the multi-host, you can use it for the production applications as well. If we talk about the cloud one, it can be used for anything, whatever you want based on your requirements. So it's useful for production application, and it's easy to scale. If you want to test also, you can easily do it, and then you can expand your infrastructure. So this is how we are having different infrastructure or environment for Kubernetes that we can define based on our requirement. So now it's time to talk about benefits of Kubernetes in DevOps. So as you know that Kubernetes helps DevOps practices by automating deployment, scaling and management. So first benefit, we are having automation. So it automates many manual tasks, reducing the chance of human error. Next is scalability. Kubernetes scales applications effortlessly in response to the demand, and the reliability also it provides that ensures high availability by distributing containers across multiple nodes. So these are the key benefits of Kubernetes in DevOps domain. That's why we are able to deliver software faster. Next thing, now let's summarize today's session. So Kubernetes is a fundamental technology in DevOps and cloud computing, and it also offers powerful tools for container orchestration and application management. Now the thing is how you can move forward with the DevOps and cloud journey. Just explore more in depth Kubernetes, and also you can do some certification or some advanced course related to Kubernetes to grow faster. So see you in next session where we are going to talk about Kubernetes resource management, Kubernetes networking and storage. Till then, happy learning, keep exploring, keep transforming. If you like this video, click on like button, share with your friend, and don't forget to subscribe. Hey guys, welcome back to our 100-day challenge, and today is day 14, and today we are going to talk about Terraform. So let's start. Why we are saying Terraform is building the future of infrastructure? Because Terraform is such a powerful tool that used as an infrastructure as a code, where it defines everything which is required for your application, like a server, virtual machines, or any component, even the networking component. We can define those components now as a code, so we can reuse it. Are many advantages if we can use it as a template, so are many chances that we there the component which or application which we are building or provisioning will be error free, because we are using the same template every time. So let's start what exactly Terraform is. So if we talk about what exactly that Terraform is, open source infrastructure as a code tool, which is created by Hasiko. So the thing is, a Terraform tool can be used to create, manage, and destroy infrastructure resources. What are these resources? It can be your server, virtual machines, or any application. Okay. So normally Terraform uses state file to track the changes of your current environment and what gonna be the new one. So it uses many important files that we will talk about in upcoming slide. But let's understand what Terraform can do. So Terraform allow users to define and manage infrastructure as a code, which increase automation and reduce the risk of human error. Now the thing is why we are using Terraform, because it provides flexibility, because it works with variety of infrastructure providers, including cloud services and on-premises virtual machines. When we are talking about cloud providers like Azure, AWS, and Google Cloud, whatever cloud you define, Terraform supports those cloud platforms. So now let's talk about what Terraform can do. So Terraform can be used to create code, connect components, and execute the code what we created for our infrastructure components. So here it is mentioned that Terraform code uses a simple syntax to describe infrastructure component using providers resources. It can help to connect components of the infrastructure which ensure smooth deployment and scaling, and it can help to execute the code to the new infrastructure component and implement updates to the existing one. Not only we can create the new infrastructure with this code, but also we can update those infrastructure if there is any changes in future. So it's a so much powerful tool that now we can code our infrastructure as well. Next thing, will this work with the other tools as well in our environment? Yes, it works with many other tools and support them. If we talk about Git, it can work well with the Git that help us to provide version control of our code. Next thing, we can also integrate monitoring tool like ELK stack with our Terraform. Terraform supports several configuration management tools, what we are having like Ansible, SAP, and Puppet. So these are the few tools I am just naming here because right now we are just going through the high level overview what Terraform can help us. So it can integrate with other tools as well. If you have the knowledge of other tools, then it will be easy for you how you can correlate or integrate it. Next thing, there are few important files related to Terraform when we will work. So main.tf file is where our whole project information is documented, and in this file itself we mention providers, resources, everything there. Okay. Next file is .tf state, that is our state file that stores the Terraform state of the infrastructure after the deployment. This state file actually a JSON file format that contains the name and type of each resources, the current state of each resources, even it have the relationship between the resources. Okay, so this state file is very important because it is used by Terraform to track changes to your infrastructure and to apply those changes. Next file is tf.var file. This is variable file for a Terraform project. So we can define object as a variable as well. Next thing, what are the providers supported by Terraform? As I already mentioned, AWS, Azure, Google Cloud, whatever cloud you mentioned, Terraform support all the cloud providers. Where we can use it actually. So we can use provisioning of resources in the cloud. We can use Terraform for continuous delivery because it can be used to provision infrastructure incrementally. Terraform also support automation because we are using code so that we can use in script and it can be run whenever we want. It also can be used for creating large scale geographically distributed systems and networks, as I mentioned, not only for servers or virtual machine, but also we can create or provision networking resources as well. So it is having the capability to deploy your whole infrastructure for your organization. Now let's talk about what we learned. As I mentioned, Terraform reduce complex because Terraform simplifies provisioning, configuration, and deployment of infrastructure component. Next thing, it provide improved efficiency. Terraform is a cost efficient and time saving solution that enables infrastructure automation. And the last thing, future optimization. Terraform lays a strong foundation for future infrastructure optimization and its expansion through its code. So that's it in this video for today's session. Today we have gone through the high level overview. In the next video, we will talk about more in deeper. See you in next video. Till then, keep learning, keep exploring, and keep transforming. See you in next video. Hey guys, welcome back to our 100-day challenge, and today is day 15 where we are going to talk about in more detail. Here we will cover all the important files and how these files will look like. Let's go directly in the section. So first let's understand what you are going to learn after this session. You will understand Terraform in more simple way. Next we will talk about the all important points that is related to Terraform which you need to consider while working on Terraform. Next thing we will understand Terraform configuration files, how these files look like, so it will be easy for you to understand how Terraform files is different than the other configuration files. Next we will talk about the state file which is one of the important file among all because and help us to track the changes. Now let's understand what is Terraform. So Terraform, as I mentioned in previous session, it is an infrastructure as a code tool that is used to create, manage and destroy infrastructure resources, and it is created by HashiCorp. So with Terraform, we can define our infrastructure in code and then we can use Terraform to provision, update or destroy. Next, Terraform uses a state file to track the current state of your infrastructure. Then how this file can be created? We can create this file manually, or once we will run our first Terraform command, that is Terraform init, that is for initialization. Once we run this command, our Terraform state file is created along with the initialization of our working directory of our Terraform project. So this is how we can define Terraform. Now let's understand the important points. So Terraform is an IAC, means infrastructure as a code tool, that allow us to define our infrastructure as a code. Next point, Terraform can be used to manage infrastructure resources across multiple cloud providers. Whatever cloud you want to work with, you can use Terraform to provision, to manage or to destroy the resources. Next thing, Terraform uses a declarative language. That means we can tell Terraform what we want to do and how we want to achieve that one. That all things we can define in simple language. The only thing, it's a little bit coding part, but once you will see that coding file, you will understand easily. It's not that complex, trust me guys. Next thing, Terraform can be used to automate the creation, management and destruction of infrastructure resources quickly. That's why it is one of the most popular tool in a DevOps domain. So whenever we talk about infrastructure as a code tool, we always go with a Terraform most of the time, we can say. Next thing, how the Terraform configuration file look like. If you see this file, you can see this is a main.tf file. That is the extension. Terraform file, mostly the extension will be .tf. TF for Terraform. Okay, here you can see some information related to provider. Here you can see the provider information. Here we are using AWS and the region. The region we are using US East 1, where our resource will be created. Next is resource section. Here you can see it is creating AWS instance, name of that instance, what is AMI ID it is using, what is the instance type it is having. Similarly, we can define output. So this is a common, or we can say simple Terraform configuration file, where in single file we have defined everything. It is good for testing purpose or development purpose, but it's not ideal for the production, or we can say the large infrastructure, because it will be very confusing later point of time. If you need to make changes in any one of the place, you need to make changes for every file, means every place wherever we mention it. So we are dealing with different files in Terraform. What are those files are? If you see, first you can see the tab provider file. Here you can see Simply we are using AWS here. It can be Azure, it can be GCP or IBM cloud, whatever cloud you are using or provider you are using, you can use that one. And you can define the configuration of that provider, what you wanna use. It's not only because this region, but also you can define other parameters as well. Next file we are having resource file. Normally we define this resource in a main.tf file, but we can have this file as well. Okay. So we can define this resource file resources in our Terraform main file, that is our main.tf file that defines the resources that we want to create, manage or restore. Next file we are having variable file. This file actually defines any variable that we want to use in our Terraform configuration. When it can be used, so see, example, we can see here you can see the variable we are taking AMI. The type of this variable is string and the value of this variable is this AMI ID. Okay. With the help of this variable, we can create one resource here, we can create another resource here. Okay. But the thing is, if you see in the long run, if you want to update these instances, so if we define these all resources in a single file, but we are not using variable, then we need to go to every place and we need to define this AMI ID everywhere in our file. But if we are using variables, then what we need to do, we just need to update this variable file here and we need to change the value in the variable section. Then once we will update this configuration, automatically all the resources will be updated with the current value variable value. So this is how we can use variable to for the large updates, or we can say large modification in our infrastructure. Next file we are having output file. If you see output file, here the output is public IP. Once the AWS instance is created, it will give us a output like AWS instance dot example and the public IP in the end. So it will help, it will give us public IP that we can use to access this instance which we are creating. Next file you can see, this is a file state file where it is showing which instance is created, what all the instances, if it is created one, then it will show one. Otherwise, whatever resources we have created, it will track the changes of everything here in this file itself. As we mentioned, we can create this file manually or it will be created when we'll run the init command. Next, we are having Terraform module configuration files. We can define modules. Let's understand what exactly these modules are. Modules are like a function which can be invoked whenever we want it. Okay, so this is like a reusable piece of Terraform code that can be used to encapsulate common infrastructure pattern that we want to use again and again. For example, if you see the simple file here on the left hand side, here we define the VPC, virtual private cloud in AWS, and the value of that one name, and we are defining CIDR value, that is the subnet. Okay, so based on this one, our configuration will be created. If we want to give more information in this module, we can define like this way, which availability zone it will take place and what are the public subnet it should use, what are the private subnet it use, what is the security group it should use, or it can be used by your resources. Everything we can define this module, and we can use this module as a function. So we no need to write again and again same information. So we can use module configuration file along with our Terraform file. So it helps us to perform our tasks easily and rapidly. Now let's understand what types of files we are having. We have already seen what type of file, how it will look like. But now let's understand one by one. First file we are having main.tf file that we see. Either normally we define the resources in this file, or we can also define everything in a single file that is known as main.tf file. Next file we are having providers.tf file. Providers.tf file actually defines the cloud providers and their configuration that we want to use in our Terraform project. Next file we are having variable file. This file actually defines any variable that we want to use in our Terraform configuration, and it allows us to reuse values across multiple resources and make our Terraform configuration more dynamic. Next file we are having output file. which defines the output that we want to generate from our Terraform configuration. And it's useful for displaying information about the infrastructure, or we can use it for passing any value to other tools or application. Next file, we are having module configuration files. These files are like a function that we can use it. It's like a reusable piece of Terraform code that can be encapsulate common infrastructure pattern. Next file is state file. This file contains the state of our Terraform infrastructure. So we can use this state file to track the resources that is created or managed. It's like a simple JSON file that contains information about the resources that our Terraform configuration created. It can be anything like resource ID, resource attributes, or any dependencies. So Terraform uses this state file to prevent duplicate resources from being created, and also it ensures that resources are destroyed in the correct order we want. Normally state file is big section. We will see the initialization phase means Terraform initialization in separate section. For the timing, just understand state files is used to track the resources that it has our Terraform configuration created or managed, and also help us to prevent duplicate resources from being created. So guys, that's it in this video. I hope you find this video helpful. If you find it, then don't forget to click on like button, share with your friends for better reach. Till then, keep learning, keep exploring, keep transforming. See you in next video.